Now let's go to the algebra. In order to help you understand the number of free variables, I'm going to introduce a concept called the rank of a matrix. Since we skipped quite some content of the standard linear algebra, I give you a shortcut kind of definition. If you follow the Gauss-Jordan algorithm, make as many zeros as you can, and change this matrix into the upper triangular matrix. And then you count how many rows of zeros left. The non-zero rows, the number of non-zero rows is called the rank of the matrix. So in our example 2, the rank is 2, and the variable number is 3, and then your free variables is 1. So the rule is the number of free variables equals the number of variables minus the rank of the matrix. The rank simply tells you how many independent equations you have, period. The rank tells you how many independent equations you have. Now, just like the last example, I can keep multiply the same constant, make as many equations as I want. Start from one equation. You can make as many as you want. But that does not mean you have this many equations, because essentially all of them are the same equation. In that last example, you only really have one equation. The rank of the matrix is 1. The freedom of the system is 2. So this rank measures how many real independent equations you have. It's a very important concept for linear systems. And that concept is not only limited to the 3D. Let me just summarize the 3D. In the first example, you have a unique solution. You have 0 free variable. You have no free variable. You got a unique solution. In the second example, you have 1 free variable. That's why your solution is on the straight line, because your rank equal 2. The third example, you really only got 1 equation. The rank equal 1. The freedom is 2. And then you get a solution in a whole plane. A plane is a 2D manifold. So let's look at this example to extend the concept from 3D to 4D. And in this example, I have 4 equations. I write into the standard form with 4 rows, and then the right hand are all 0 put on the side. And we do the same kind of calculation, but just simply realize the second equation is twice of the first equation. And the last equation is negative 2 times of the third equation. You just let the second minus twice of the first. You got all zeros here. The last add twice of the third. You got all zeros. And finally, you make this one to the first, this one to the second, and then that's all left. And the rest two, the third and the last and the second, you swap it down, they're all zeros. So what does that tell you by the definition of rank? That tells you the rank equal 2. The rank equal 2. And how many variables we have? 4. How many freedom we have? 2. That's it. So we have 2 free variables. And now we're going to solve the system by take advantage of the two free variable. What I'm going to do is let the last one equals t, the z equal t, w equal s. You see, z equal t, w equal s. And by the third equation, I can solve the y equal 3/7 t minus 3/7 s. Look at the third equation. It's right here. See, 7y minus 3t plus 3s equals 0. 7y equals 3t minus 3s. Then y equals 3/7 t minus 3/7 s. And then put into the first, you can solve the x. I'm not going to go to the detail. Then once you find the x equals 2/7 t and minus 2/7 s, you rewrite this solution into two vectors. T vector, t times one vector, s times another vector. So what does your solution look like? It's a two-dimensional manifold. So you cannot call it a plane too, because it's two-dimensional, two freedom. But if you don't like the fraction over 7, you can remove it by later this st, the t equals 7u, s equals 7v. I just don't like the fraction 7. You plug it into here, you get this better look solution. Well, when you have infinite many solutions, rarely you have only one way to write it. You have all different ways to write. Because, look, if I have a plane, I want you to write the plane equation, you can select any two vector. Write it as a combination of the two. You can select this way, that's all your choice. Or you can make the vector longer or shorter, like this to make it longer, 7 times longer. That's fine. You just wanted to remove the fraction. So it's not unique. But you know what it looks like. It's a plane. And this time, the last thing I want to do is show you how to use the MATLAB to solve such a messy system. 2 steps. The first step, I make it all 0 here. And if you make it all 0, you get a homogeneous system. Homogeneous system. When you get a homogeneous system, you know you always can get solutions. That's the advantage. Your solution to the homogeneous system have a name. It's called the null space. Null means make it 0. If you look from the transformation point of view, you really look at the vectors whose image equals 0. Equal 0 means null. Null space means all the vectors project to 0. So in this case, the step 1, you input the 2 equations because we really only have 2 independent. And you get this coefficient matrix. And then this one just tell you you're going to use rational number. You can use decimal. If you don't write it down this, you're going to get all these fractions, decimals. And the true command line is this. Null A, the coefficient matrix, and little r means rational. Then you get your solution. Because you have 4 variables, the solution is going to be a 4 component vectors. And that's exactly what you see I did a moment ago. That's the solution I showed you here. You see it? No, here. Yeah, that's the solution I showed you here by hand. But that won't have a different if you do by MATLAB. what's next? Next, you're going to find the one particular solution with the right hand B7 and 14. Basically, you ask the computer, could you find me just one solution? You have infinite many, find me one. Make this solution past the point 7 and 14. Then you put the right hand B equal 7, 14, and you divide A to B. That backslash line means A divided by B. It's really like a kind of inverse, but close. And when you get this, they give you one solution here, look a little bit weird. The second element, I would bet you can be just 0. You make such a small number, it's just a round error of the MATLAB. We're going to talk how MATLAB solves that in the next module. So step 3, you add the null solution, homogeneous solution to the particular solution, then you get the solution to the system. So step 1, solve the homogeneous one. Step 2, let the MATLAB find you one solution. Does not have to look like that. In the end, you add the two together. But still, you remember, you have 2 freedoms. Because 4 variables, only 2 equations. That's why you end up with 2 solutions. So today, we really present you all different situations of system equations. In your high school, your focus most given to the system, you find the unique solution. You might mention that sometimes there's infinite many solutions, sometimes there's no solution. Nevertheless, and here we just extend it to more variables, and I would like you to focus on the relationship between the algebra and the geometry. Then you understand what this different situation mean, like the concept of rank, number of free variables, and the Gauss-Jordan algorithm. And you understand this, then the algebra will be less abstract. All right, thank you. This is for today. And for the next 3 hours, we're going to look for applications. And especially the concept of eigenvalue and the eigenvectors we briefly mentioned in the first 3 hours. So see you next time. Thank you.